find the moment of the given force above point A. To solve a problem like this, first you need to express R in Cartesian. In this particular example, R is from point A all the way to point C because we are taking moment above point A. Then step 2 is going to be expressing F in Cartesian. Now that you have these two, step 3 is going to be forming this equation to find M, which is R cross F. Let's start with expressing R. A is origin. It has x, y, z as 0, 0, 0. So if you write C coordinates, it's going to be easy to find R. Now, given dimensions are in millimeter, I write all of them in meters. So C has x component of 0.55 meters. So this is 300 and this is 250. Together it's going to be 300. And its y component is 400. That means that it's 0.4. And z component, you can see that it's negative 200. That means that it's going to be negative 0.2 in meter. Therefore, R is going to be 0.55 I plus 0.4 J minus 0.2 K in meter. This is our R. Now let's write F in Cartesian. When you see two angles, that means that one of the angles, which is this one in this example, is showing the angle between the force and the plane. In this example, plane is x, y, because you can see that this is parallel with y and this one is parallel with x. Therefore, F prime is going to be F cosine 30 degree. You need first to find this one, and that's going to be 69.3 Newton. Now, F prime is this force that acts in here. This is our F prime. By looking at this given angle again, you can see F prime cosine 40 degree is going to be Fy, and F prime sine 40 degree is going to be our Fx. So I'm writing, so Fx is F prime sine 40 degree, and if you solve it, it's going to be 69.3 times 0.643, and that's equal to 44.5 Newton. Then Fy is F prime cosine 40 degree, because adjacent is 40 degree adjacent to y-axis, and that's going to be 53.1 Newton. Now we need Fz also. Based on this given angle, which is 30 degree, Fz is going to be F itself times sine 30 degree. But because it's acting in the opposite of z direction, I have to put a negative in front of it. It's going to be negative F sine 30 degree, and it's equal to negative 40 Newton. That means that I have F in Cartesian as well. I'm going to write it. So F is going to be equal 44.5 I plus 53.1 J minus 40 K, and that's in Newton. So I have F in Cartesian and I have R in Cartesian. Now I can form this M. M is R cross F, and that's going to be I, J, K again. My R is equal to 0.55, 0.4, and negative 2. And my F is 44.5, 53.1, and negative 40. Again, you need to solve it. It's going to be I times 0.40 times negative 40 minus negative 0.2 times 53.1 minus j times 0.55 minus 55 times negative 40 minus negative 0.2 times 44.5, and so on. I'm just writing for you guys. So I times, it's equal 0.4 times negative 40 minus negative 0.2 times 53.1. Again, don't forget this negative in here, negative j times 0.55 times negative 40. So you have to pay attention in this positive negative signs. You can make mistake in here. Negative 0.2 times 44.5 and plus k times 0.55 times 53.1 minus 0.4 times 44.5, and that's it. Now if you multiply them and simplify them, it's going to be negative 5.4i plus 13j plus 11.5k. This is our M in Cartesian, and the unit is Newton meter. This is how we calculate this moment